Good morning, everyone. My name is Ryan McAuliffe. I am Product Manager for NovaTech Automation, and today we will be going through our new release of 10.6 and NCD 3.42. I am joined by Mr. Brett Donjon, who's the sales engineer. He's based out of Texas, probably one of the smartest and youngest and brightest stars that we have at NovaTech at the moment. We'll take the hour to do basically some talk about the couple of software modules that we've released, as well as demo how they work, as well as some other Orion OS enhancements. We've got some new expansion cards, cards for the I/O. We're going to talk about OPC UA, client and server, the gas density monitor, the Postgres database exporter, and other enhancements. To get the new Orion Distro and NCD installer, please visit support.novatechautomation.com. For NCD software, click on the NCD, and for the Orion model, go to each Orion model. The other caveat, I think, to this that we don't have on the screen is if you're interested in Orion VX, you can click on that and download the latest 10.6 OVA from that page there. New expansion cards, this is kind of exciting. So with the MX, we have a couple of different new options. The E1 card is an 8-port Ethernet switch card. It has 6, 10, 100, 1,000 megabit ports, so megabit ports. They act as individual NICs, but like with all the network interfaces on the Orion, you can bond them, bridge them, and do whatever you want to. And also 2 SFP ports. One note. I'm actually going to clarify that one. The A1 card for the 4-channel analog input card. This is new to the MX. We've never had analog inputs before, so this is exciting. Channels 1 and 2, plus and 10 volts, or plus and minus 2 milliamps, or the normal 4-20. With the channel 3 to 4, definitely software selectable, plus and minus 58 volts, and the same amperage ranges on that. The higher voltage for the 58, the channels 3 and 4, for monitoring the station battery. So that should come in handy for all those who don't already have monitoring solutions for your UPS systems in these applications. The M2 meter card. We have 20 amp internal CTs for 3-phase measurement of line 1. And we also have line 1 and 2 inputs for PTs up to 600 volts. And there is one Form C relay that can be controlled by a SCADA point that you can send from your various SCADA systems. Please note the form factor of the M2 card will take up 2 slots. It will appear as the M2 in the model number when you select it in the quoting card. And it can only be installed in either this position here on C and D or in A and B. So you couldn't just install it in C and B. Primary and optimal units are supported with the meter card. For the expansion card for the I/O, we now have an analog output card. It is an 8-channel analog output. We have the plus and minus 2 milliamps, the forward 20 milliamps, and the plus and minus 10 VDC output ranges. Software selectable once again. This kind of extends the Orion I/O portfolio to include a full suite of the D20 retrofits. So now that we can replace things like the generator controllers and things like that by using the analog output card to replace, I think, pretty much everything that the D20 has to offer. So if you're interested in retrofit possibilities, feel free to contact sales.engineering@novatechformation.com. The analog outputs are traditionally used for like tap positions, transformer cooling fans, and the governor control on generators. And I believe that Brett is going to demo the I/O configurations in NCD.
That's right. Thank you, Ryan. I will take the screen from you. You can see my screen, correct?
I can indeed.
Excellent. Okay, so everyone, welcome to the webinar. A few times here in this webinar, we'll have Ryan explaining the details. I will jump in after he speaks and just show you what he spoke about. You know, he spoke on kind of the technical um, aspects of the new features that are available, and I'm going to show you them in NCD and specifically show you where to find, how to configure them in NCD. I'll just kind of show you basically what's entailed with that. So I'll go in the order he went in, and you'll see I have a few files open here, but just for the sake of being able to show you the new options on the MX, I have a file created just for that purpose. And to show you the analog card, I'm going to go to Hardware I/O, and I'm going to select I/O cards. And you'll see here, this is nothing new, of course. This is just the basic, interface that you always see. But I'm going to click Add New Card. I'm going to say that this is on slot A on the Orion MX. And here, right, we've always had this DI and DO option, but now we've added the option for 4AI, high voltage. I will select that. I will click Accept. So now, of course, you'll be able to give it a description if you'd like to. I'm going to leave it where it is, but I can now go to Inputs. And you'll see these are the 4 slots for it, and I'll just go ahead and add them all. And you'll see they display the channel number here. Of course, they're all analog. When it comes to the transducer, there are selectable values here. As Ryan had said, and as he showed on the slide, the inputs 1 and 2 are lower voltage. They are the range of minus 10 to 10 volts. So of course you can select those for inputs 1 and 2. You will see this option here for 58, but just note, if you try to select it, it'll bark at you because that is a lower voltage input or a set of inputs there. But you can do minus 10 to 10, minus 2 to 2 milliamps, or 4 to 20 milliamps for these inputs 1 and 2. For the high voltage inputs, these channels 2 and 3, you'll be able to select, again, those same milliamp ranges of minus 2 to 2 and 4 to 20. But now you'll be able to select for these the voltage range, the higher voltage range of minus 58 to 58 volts. And once you configure that, that's all there is to it. As always, configuring the I/O is very simple to do. So really, just you bring them over, set the voltage or milliamps the way you like it. That's all that we really need to do for the analog inputs. And with that said, I'm going to move on now to configure the new meter card. So it starts out same as before. We're going to go to Hardware I/O, but this time we're going to configure here this option for AC meter card. A few of you on the call perhaps have ordered the M1 card before, and that was our version of a meter function on the MX that relied on split core CTs. But this M2 is what I'm going to show right here. Let's back out of there. AC meter card. We're going to put it on card C. Here we go. So of course we can choose our defaults under here like we do with the other protocols, but you'll see the choices here are pre-populated where we're seeing the options for the old M1 card and then the combination of the M1 and C1 metering cards. But now you see two new options here where you're specifying either delta or Y for this M2 card. So just for the sake of choosing something, I will go with delta. And you'll see down here, you can configure in terms of the metering input, the number of elements. You can choose that here. We will go ahead and accept. Now, for those of you who've not configured a meter card before on the Orion MX, once you configure that, and I think a good point of clarification to make is that even though the meter, I guess I say kind of in air quotes, the meter lives inside the Orion MX hardware, NCD will treat it for purposes of configuring it. It treats it as an independent device, which means that that meter will communicate with the Orion via a DNP protocol. So you'll see as soon as I selected this, I confirmed everything over here. It popped up a client port. This is saying a serial port number 9. And typically, since I put this on card C, if you would order the serial ports, the range of those serial ports as they're numbered on the MX would be 9 through 12. So basically, we're making up a serial port. We're putting a serial port 9 on port C. We're using it. And we are configuring here a DNP client. Now, since this is internal to the MX, you'll see the serial options are already configured as they should be. So now really we have to give it a name if we'd like to. MX meter card, we'll just give it a name like that. And generally most of these DNP settings can be left alone. I will go ahead and accept. And now I will go to inputs. And you'll see just a pre-populated list of all the readings, all the data points that you can get off of that meter. So here, as always, with any other protocol, it's just you pick and choose what you'd like to see. I'm just going to select a good group of those, bring them over. I'll select the health also. And once we've selected those points, you can set a pull group if you'd like to. Really shouldn't need to. But you'll see I accidentally added a device. Let's remove that. There's no need to add other devices to this. So once you've configured the inputs, let's bring a couple outputs over too. Not much else to configure here. We're just trying to configure that to bring data in from the meter. So once that's done, we can close out. And you'll see back here when we get back to the metering screen, we had selected before, we need to change this to 3 element. And now you can configure your PT ratio, CT ratio, if you want to monitor overcurrent, some settings there for that. And then scaling as it pertains to the DNP protocol, where, since we're communicating in integer values over there, we're bringing them in like that. You can set up the number of amps per a 1 count of that DNP protocol. And in a lot of cases, this could also be referred to as the scale factor. You may see that in the some documentation on some devices you may be familiar with. But that is the Orion MX meter card. He also mentioned the E1 Ethernet card, but that Ethernet card is not something we configure in NCD. It's actually just, it populates as additional networking ports that you can configure through the Web UI's network settings screen. So now the Orion IO, the analog output card, I'm going to go ahead and open up just an IO file. I'm going to go to configure IO cards, and I'm going to add a new card here. And you'll see right here, you'll see this option for 8AO analog outputs. That is what we call type 9. I'll go ahead and accept. Of course, give the card a name if you'd like to. So now, of course, we have status points as inputs that are associated with those outputs. But for these outputs, you can configure, just take the ones you want, bring them across. Of course, you have this setting, the group of settings with the transducer. Also, something you may not be used to seeing is this option here that is ramp. Now, what ramp does, ramp dictates an amount of time that it's going to take if you have an output value set on here. And if you go and you enter a different value, and you force that control, the ramp time indicates the time it'll take for that new value to be, I guess, ramped up to or ramped down to from the old value. And so in some cases you may need some time for it to kind of transition to the new value. If you don't, you can just use the value of 0 and it's going to make just an instantaneous jump to that new value. So that's something worth bearing in mind. So with that said, I've gone through all these in NCD. I'll be back here in a little bit. Ryan, you can take the screen back if you could and continue the presentation.
Sounds good. I did just want to share a couple of questions and answers that we've had in the chat while you've been presenting.
Certainly.
Someone asked, and I should have mentioned during the presentation, that the MX can only use one E1 card. You cannot fully populate the Orion MX with multiple E1 cards. It only allows one. And someone else asked what the polling rate of the Mega card was, and that is set for 2 seconds. So now that we've got those sorted, OPC UA client and server. The OPC UA server is managed by the OPC Foundation. It has no direct ties to a specific manufacturer, so implementation can be kind of standardized with no vendor having a home court advantage. There was vendors that obviously started this. I think like Schneider was a big player in this. But because it's managed by an organization now and a foundation, everyone gets together to be able to decide where the future of the protocol goes. The standard includes a variety of different information models, and they're standardized implementations of certain parameters and data structures and device types. It is secure by default. It comes with encryption, authentication, and authorization. There is also a range of different companion standards, which can detail standardized mapping and the conversion of other protocols to OPC UA. There's a really good one for 61850, and I think there is also a good one for phasor measurements as well. It is highly secure. The encryption or authentication also contain checksums. As far as the authorization goes, you can have users with different data access. So the server can be showing all of the data, and based on the connection type, can only preview some of the data, which is pretty good for managing access to it. Does support certificates and tokens and pretty much everything. It is highly flexible. You can support some really complex data models in OPC UA. Some people can define their whole kind of IT structure with the OPC UA protocol. Very much focused, well, they're focused very much now in the regular kind of IT OT space, not just power, is like IoT for managing those. We can have both client and server type of messaging, and you can also have publisher and subscriber. The details behind that is client and server works just like a regular DNP3 protocol. So you have a client that's sending out data, and you have a server that's serving out data, and you have the client accessing that data. Whereas with publisher and subscriber, the server is essentially the publisher, so it's publishing all the data, but then you can have multiple subscribers to it, that the server has to only publish it once. Kind of similar to the MQTT protocol and other protocols like that. Applications for our space. For wind, it can do turbine monitoring and control. There's a lot of wind controllers out there that speak OPC UA. the turbines generate massive amounts of data for like wind speed, rotor RPM, and gearbox temperature. And OPC UA ensures that the data is securely transmitted and also very fast as well. With this, we can do the predictive maintenance. So with the data collected, you can help monitor the turbine health. So hopefully being able to predict failures in components like the blades and the bearings. Wind farm operators generally use OPC UA to integrate systems from different turbine manufacturers. So if you were to use the Orion at a wind farm, it could connect to all the controllers and provide a holistic view of what's going on without the head-end station having to be able to talk to different controllers in a different way. With the solar energy, a lot of the inverters and panel monitoring, you can connect up to OPC UA. You can get some real-time tracking of the data about basically the solar radiance and everything like that, and you can share that with the energy management system to show how the solar field is performing. Also good for integration with the microgrids. With the energy storage systems, it is good for battery monitoring. Can do discharge rates, charge rates, state of change, and state of health. And it's also involved in some demand response applications. And I think I'll hand over to Brett now to demonstrate how we can configure OPC UA with NCD and make it as easy as possible for you guys.
All right. Thank you, Ryan. So to start configuring this, and just to kind of set the stage with you, I'm just going to do a configuration on the Orion SX, but really believe essentially all of our Orion models can support OPC UA. So, but I happen to be configuring it on an Orion SX. And for a little bit of background, I do have OPC UA configured, really some of the server aspects of it configured on my demo Orion IO. And I'll show you the basics of configuring both of them, and then I'll be able to show it to you live. So I'm going to go configure a network port. OPC UA is a network-only protocol. So I'm going to configure a port here. I'm going to select OPC UA, and you will see that it is a client/server configuration here. So I click OK, and we will open up the configuration screen, and you'll see we have a section over here for client and a section for server. And I'll show you how each of these work. So I open that up, but I'm also going to open this Orion IO where I have that configured here, just to kind of show you how to configure the server first and then the client. So you'll see when we open the OPC UA client server screen, just really right here under port, they hit you right away with, of course, you can name the port, but then right away you see the security things that come in, which when it comes to the OCP UA, security is a huge deal. You'll see here there's the certificate file, key file. We're specifying these, specifying a password if we like, and where we're going to store the certificates. And once you configure OPC UA and once you put it on your Orion and you're running it, I do believe that these certificate files, or at least the one for the local Orion, is generated automatically. So the information for that's configured right here. So let's say on this device we are configuring a server. So I can click Add New Folder. The folders are basically containers that can hold the various groups of points. So you'll see you don't have to make multiple, but I made one for discretes and I made one for analogs. And you'll see I kind of configured them accordingly. I don't have anything else configured on this unit, so what I actually did is, you may recognize these. These are just Orion internal status points. It's a combination of both discrete points and analog points. But you'll see here I took the discrete points from this list. I brought them over. Not much else needs to be done with these if you're configuring discrete points. Now with analogs, I brought over the group of the analog inputs here. And here is where you can set the deadband. Of course, the deadband, just really with all of our protocols, that dictates the change in the end log values and what's considered as a change that can be reported in kind of an unsolicited fashion as point value changes. So that's something you may need to set here. Not much else to mention there, but of course for each of these we can configure both inputs and outputs, and outputs are really configured in much the same way. One thing that we're not used to seeing that we see in this protocol, instead of really what we normally do, this is a little different. You'll see a button for adding a new endpoint. And what an endpoint is basically is we're giving the protocol is essentially here giving the client device something to connect to. When we refer to endpoint, that's essentially what we're saying. So here, we're giving this device a name. We're just calling it Orion IO, but then we're going to pop in the IP address of this Orion IO. This TCP port is default. And then, of course, if you want security associated with it, you can do that too. There are a few options here. Security generally in an application using OPC UA, you're pretty much always going to want it to be secure. There is a checkbox here to allow anonymous access, which, as I understand, essentially disables security. We have it available. In most cases, you're going to want security with this, but if I'm just demoing it, I prefer that security not potentially cause problems with my demo, so I'm going to keep that checked. So again, this is on my Orion IO, and this is going to give my other device, which is an Orion SX, something to connect to come grab these points. Having shown that, we're going to jump back over here. Again, this is the Orion SX file, and I'm going to here configure a client device. So first thing here under groups, you can set the default pull group here. So this is the polling. This is the client server relationship polling, similar to your DNP and Modbus and other protocols. And we have it polling every 2 seconds. There is a separate group, and you do have to add your points to this group if you want them to report on a subscriber basis. And there is a checkbox here that tells the Orion that this is based on that kind of subscription, the publisher subscriber system. And you'll see we can set this here, time interval also. We set it to 1 second. We can click now to add a new device. We will give it a name. We will call it, I'll just call it Orion IO. So here we're going to pop in the IP address that we want to connect to. So that's going to be the same as we configured on the other screen. That is the IP address of my Orion IO. Now, on some devices, if we have maybe a more advanced kind of a URL path, you can see I can type things into this /OrionIO/home or whatever. This would be configured, this path, on that server device. You don't have to do it. I'm not going to add a URL path. We didn't do that on ours. So that functionality is there to point it to a specific place on the server device. We have some timeout settings. And of course, once again, we have security as an option here too to match up with the security that we set on the server device also. With that, you will also notice, let me go ahead and accept here. You guys will recognize this portion of the screen. This is for the default files that we'd have in most of our other protocols. And if you recall, it allows us to capture points we configured maybe on another device. It allows us to essentially save them and use them, recall them quickly if we're configuring multiple devices. OPC UA handles this a little bit differently. Once we've populated all the information down here, we can click this button that says Browse. This is going to go to this IP address. It's going to go and try to pull the OPC UA point list for our use here with the client to go and pull those points. So just like any other protocol here, we can specify a manufacturer name. I'm going to say NovaTech, and let's just say the model Orion IO hour. Just, of course, so I know what that is. I can click OK. You'll see a little status screen over here. It'll tell you that it's successful, and I'm going to click OK. So now on this list, you'll notice it populates automatically, and that's a little different from our other protocols where you would have to restart the NCD program to get that to populate. But I'm able to select that straight away, And I can go now under inputs, and you'll recognize these. We configured this on the Orion IO side. So we can bring these points right over. I would go so far, and Ryan, if you disagree, feel free to break in. I would say that browse option is strongly recommended to use. It makes life a lot easier. You will see here under node ID, we have these kind of NS equals 2, NS equals 3. Those are a thing called a namespace index, I believe is what it's referred to. And you'll see for each of the different points that we put in the different folders, each of those folders generated its own namespace index. And if you're configuring this on a client, that is information you need to know. That is something that we need to populate correctly under the node ID. And I would expect if that's not populated correctly, that those points would have difficulty being transferred over, which again is why if you just click browse, you pull those points in, that sort of thing, making sure those are right is not necessary. It will be right because it's data pulled directly from that other device. That is really all that's entailed in configuring the client. So with that said, and just to kind of point out the interface here, you'll see that it's much the same as our other protocol screens. We can filter by inputs here. There's Booleans here, different types of points also if we had them configured. And I'm gonna stop with the detail on that because many of you know how our other protocol screens are configured, and it's pretty much the same. So I'm gonna go ahead and save all of this. Now I'm gonna jump over to the web interface, and you'll see right here I have my Orion IO web UI and I have my Orion SX web UI. And as you'll see, I did kind of preload files onto these because I'd like to get straight to showing you what it looks like on here. So with the Orion IO, and you'll see it's forcing me for login. That's fine. Jump over here for a second. I'll do the same. Okay. We can go to data values. We can see these inputs kind of configured here. That's boring. That's just what's locally configured. If I go to view comms for this, I can jump into OPC UA, and you can see since we set that kind of subscriber point interval to 1 second, what it's doing in response to that is every 1 second it's checking, roughly every 1 second, it's checking to see if any point values have changed. So that's what you'll see on the communication stream here. On the other side, this is the SX, the client. Of course, under devices, we'll be able to see and verify the polls and responses that's online. Under data values, we'll be able to see the data that we're getting from the Orion IO, and you'll see, we have some reasonable points populated in here. But what's view comms doing on this side? This is based on the polling interval, right? It was every 2 seconds. It's basically showing it's bringing new values in for all these points. And this is the poll from client to server. That's the communication you're seeing here. So I just wanted to show you what that all looks like. As far as, again, the most basic of configurations, I was able to show you how that works. I believe that's pretty much all I have to show for the time being. So Ryan, I'm going to kick it right back to you.
Sounds good. Thank you, Brett. Next up, gas density monitor. I would like to point out that the next two things that we're going to talk about, the gas density monitor and the database exporter, are kind of close to my heart. As a product manager, the kind of first really detailed specifications I ever did and saw to completion. So I'm kind of quite proud of these myself. The gas density monitor for SF6 utilization, SF6 is kind of being pretty prevalent in the power industry to maintain insulation for circuit breakers and transformers, and it's growing steadily. There's a lot of investment in it, but it does have nasty side effects for the environment, so monitoring it is crucial, not only because it's very expensive gas and it costs a lot to replace it, and also if you have to replace it, you're taking an equipment outage on it, but also for regulatory requirements. Some ISOs maintain that you have to maintain them every X months, I believe. It is driven by the demand to have more compact and reliable high voltage solutions. You can actually have like a whole SF6 gas substation called GIS substation that reduces the footprint, I think, by, and I could be wrong, I don't have this in my notes, I could be making this out of the top of my head, but I think it reduces it by like 25%, by 75%. Because everything's in the insulated gas, you don't need like a wide footprint for your substation because the clearance levels are very much shorter. It is used widely because of its insulation properties. It's got a high dielectrical strength and arc quenching capabilities. So the circuit breakers and transformers, it's really good. So in order to use gas density monitoring on the Orion, a key component of this is SF6 sensors. We don't supply those. You'll probably either have your own already, and if you do, we can just connect up to them. And if not, definitely feel free to purchase them. We take the Modbus, either the Modbus output or a 420 input signal for the gas density. The gas density read by these is generally outputted based on the pressure at 20 degrees centigrade. So it provides a kind of standardized, kind of temperature controlled monitoring of the density. So that when the pressure goes up and down because of the external heat or the external cold due to the weather, you'll still get standardized calculations about the actual volume of how much SF6 gas is left. And I am going to do the demo now. So in NCD, I think I can just also start up a new file. I've already got one configured, but I'll start a new file on this just to make it easier to show from the get-go. So it's under add-ons. Looking for, okay, everyone can see that. No one's complained yet. Gas density monitor. You can change the port name if you like. You can decide to declare it if it's a GIS substation. That tick box doesn't really give anything at the moment. So if you click accept, and you can add a gas compartment. So you can name this, generally you would be naming this like what, if it's a breaker or a transformer or whatever you like. So I'll use a nice Australian voltage. And so with single compartment, the single compartment tells me that all three of the phases for the breaker are in the same gas compartment. If you do a 3 compartment, then that means that each phase is separated into different compartments. So each compartment will have its own sensor. We'll show 3 compartment because it's just slightly more technical. So when you do, you can get your phase A, your phase B, and your phase C. There's notable things in here. The annual gas leakage rate will be coming from the gas insulated manufacturer. So you'll put that in there. The leakage rate threshold, I think the manufacturer will also tell you what they consider allowable leakage rates. And this is kind of also probably from the manual, they'll tell you kind of when it should be kind of noted that you should replace the SF6 gas or that it needs maintenance. And this is a kind of, it needs maintenance really, really now, stage 1. It's kind of basically almost close to, the equipment is almost close to lockout. The automatic trend reset over 21 days, if the gas density monitoring system has noted from, say, okay, so 21 days ago, if the gas density was something like 4.2 kilograms per meter squared, and it suddenly jumped to 6.2 or 5.8 or whatever, and then trended at 5.8 or near that level for 20 days, it will automatically assume that you have refilled the gas, and it will do a trend reset on the graph for that compartment. So you can choose to do the automatic trend reset to make sure that you don't have to rely on when the operators go out there to replace it. I think it's quite handy, but you can also do a manual trend reset, and I'll show you that by the web UI. So you just need one point for the server input, and that is the gas density. I don't have anything right now, but let's just say that one. You can't put any more points in, it will just replace what's there. As far as the client inputs, we don't really need to bother about these. These are kind of for the internal workings of how this subsystem works. So it's slightly different than kind of most software modules. So you really shouldn't actually do anything with these at all. Just kind of leave them there. It will automatically populate these as the system runs. So when you do have server inputs, you'll be able to save it. Actually, you can save it without server inputs, and GDM will complain when you have done so. So just have fun. This is the configuration that I am running currently, so I just thought I'd show you so it wasn't any surprise. So based on our sales demo configuration, I just have 3 figures there being monitored. And I put a dummy just to show what that looked like. So going to the web UI, kind of like the enunciator page, it has a page called /GDM. If you do want to map this as a link, it would be the same way as you would do the enunciator. So under settings, web UI, link bar, and you could add an address for /GDM and then the link name. And you can also do the same. That's it, right there. So with the actual GDM, you can note the status here. I didn't get this demo quite worked out as much as I wanted to. So they're all showing red. Only 3 or 4 should be showing red. But regardless, if you click one of these, it will then show you the trend date from whenever you really want. So you can change it over a year, 6 months, 3 months, 1 month, 1 week. You can save everything to CSV, and you can do the same for the leakage rate. So that was density here, and this is leakage rate. You can reset the trend data here, like I mentioned before. If you know that you've replaced the gas, you can hit the reset trend data, and that will reset it back to either the installed from NCD or what I think it should give you. Okay, so if you reset the density and date, you can confirm that it will do it based on the NCD file. I think that's all for GDM. I probably should have just shown, actually, yeah. With the Postgres database exporter, we now allow you, or not allow you, we now have an option, a software option for you to export the Orion Postgres database to a remote Postgres database. The idea behind that is you can combine multiple Orion databases for reporting on the one Postgres server. This enables you to have like permanent offsite storage access of the database records, which is, I think, vital in today's world. You can have a centralized by sequence of events database and a centralized archive of everything that's going on in the substation using it. It will transfer the archive, both the archive for the analogs and also the alarm archive. So if you've got binary or analog alarms, it will save those as well. While the database exporter will do its best to kind of maintain its own state and make sure that it doesn't outgrow, there is no limit for the growth of the remote database. Database exporter doesn't kind of maintain the size of that. So the remote database isn't actually supported by NovaTech. The integration is kind of up to you and your IT team. But we do have IT OT services that you can use that you can contract that out. But it's not part of this actual package. So in NCD, I'll just show you the one that I've already pre-configured just so that it's easier. Noting here, this description actually sets the Orion ID in the database tables on the remote database. So it should be descriptive and it should be unique to each Orion to make sure that it doesn't kind of stomp over anything else. With this, we do have an input status point and an output exporting point. You can send these to SCADA. You can also kind of play around with them in Lua if you needed to. But this one will show you the current status of the database, make sure that we are doing the syncing as we need to. This block exporting, if you ever need to if you need to do remote database maintenance or something like that, you could stop the export by sending a SCADA point to the Orion. And I think that's kind of quite handy. So getting up, I've actually got two configured. They're going to the same server, but I just wanted to show you that you can configure multiple destinations for the database export in case you've got like a primary data center and a secondary data center. You can control the output for both connections as well, and also overall. So going over here, the description, this doesn't really matter apart from viewing it in the web UI, the host name of the Postgres server, the port that you want, the database name. Generally, Postgres installs with Postgres as the database name. You can change that as seen here. I create a new database and call it export. You can call it whatever you want to, as long as you make sure that it matches between the remote database and the Orion. Username, password, you can set up SSL mode to make it secure so that you can encrypt the data while you send it. The write limit for network constrained sites, you can change the write limit so that it's only like it only inserts 10 records at a time. What this does is that when you export any kind of database rather than just sending, each individual query, you can do like a start stop of data filling essentially. So what the write limit does is ensure that, hey, there's actually going to be 50 data points. It's going to start it. It's going to send the data points, and then it's going to commit the data. If at any point during that process, before it commits the data, it gets disconnected by a comms problem or whatever, that change automatically gets written back. Just kind of security to make sure that comms interruptions don't ruin the remote database. The archive mode for backfill and new, so if you had an existing database and it has a lot of, has years of data, you can choose backfill and it will send everything it's ever recorded over to the remote database. And you can set the archive interval here, depending on your preference and your want of how often the Orion sends the database. From the web UI, there's actually kind of not much to show. You can view comms for the data export. It will, every archive time, it will show things like that. And yeah, my server's not running at the moment, but that's basically all you can see from here. And I think we are actually running behind time. I'm noting, so hurry this one up. Orion OS enhancements. PTP over HSR and PRP. So with the software option of HSR PRP, which runs over the standard network interface cards on the Orion, you can now use Precision Time Protocol. The 61850 MMS dynamic data set, that allows the Orion to basically contact the relay or the IED on site in the 61850 and go, hey, what have you got to give me? Instead of just configuring on the Orion everything or all the points that you need to poll. With the DNP enhancements, we now have a tick box that Brett will show you, basically that we can request the link status. This actually puts us in compliance with the DNP3 standard. So if you've got unsolicited servers out there that just only send communications when something's wrong, and it might not send anything for 6 hours, 10 hours, might not send anything for 20 days. But you still want to know whether that communications channel is up and working, then you would use the request link status to make sure that you are still in communication with your unsolicited devices.
You're right.
Yes, sir.
This is probably a pretty good time for me to take over. I can show those in NCD kind of as we're talking about them, but I'll go ahead and take the rest of this.
Go for it.
All right. Yeah, so he mentioned the first DNP enhancement. Let me go ahead and open NCD back up. See, I've got another file up. I have a device configured, and the what he was referring to was the reset link, and you'll see there's a checkbox right here for that. It's pretty much what Ryan said. There's not much to add to that. The second thing we added in is this keep alive timeout, and you'll see it set to 30 seconds by default. That kind of dictates, I think you kind of talked about this too, but this dictates an amount of time in milliseconds that the client device here, as we have it configured, waits with the server device idle before it sends a communication, just what's called a request link status. And the purpose of that is just basically if you were talking on the phone to someone and then suddenly they went, silent, after a few seconds, you're going to say, hey, are you still there? And that's the purpose, as I understand it, of that keep alive timeout, just to make sure that that other device is idle, not disconnected. And I guess lastly here, this integrity pull when in trouble does a pretty good job of explaining what it is, really just by the description there. There is a trouble bit that a server device can set, in its messages to the client. And what this does, if the Orion sees a communication from that server where that trouble bit is set, it can respond by sending integrity pulls. It also will just pull it a little more frequently, just kind of as a precaution, as a response to that trouble flag. So if you leave that unchecked, you'll see it's checked by default. If you would leave it unchecked, basically that just means that the client is not going to respond in any way based on that trouble bit. So yeah, as Ryan had said, that's he kind of gave the reasoning for adding those features in. I don't know that they're going to be widely used, and in almost all cases, leaving them as default is going to be just fine if you're not sure. But the other two things on there, we've added a new features. We added 2 new calculations to Logic Pack, and we revised one of our calculations. So let me show you that. I'm going to open up Logic Pack. Logic Pack. Okay. So now, under Logic Inputs, and I'll make this bigger, you'll see a new function down here called Data Selector. And you'll see it lets you add a bunch of points in. Just going to add, and guys, these are kind of nonsensical. I'm just adding a bunch of points to kind of aid in explaining. Don't pay attention to the points themselves. But what the data selector does, and you guys may be familiar with the primary secondary function here, where you're adding a point here that's really, it is kind of your highest priority. If this point's online and if there's a data point available, if there's a value available, then this kind of resultant point is going to use that value. If this point is offline, well, then it's going to jump to the second point. If it's online, then the resultant point then is going to take the value of that secondary input. Now, we took that concept, pretty much that exact concept, and now under data selector, you can add 3, 4, 5, 6, 7. Ryan, I'm sure there's a limit, but you can add a ton of points where just this resultant point here will always report the value from the online point on this long list with the highest priority. So it's kind of primary, secondary on steroids. It's primary, secondary, tertiary, etc. So that's what this is. We did have a customer request the addition of this, and it has its applications, but I wanted to explain that to you. Next, under outputs, we have control link as a new function down here. So what this does, and I think this is a bit more intuitive, the application for it. So if we go add a bunch of points, and typically this will be points, maybe identical points from different devices, it'll be controls. The idea is that this point you will put, in a server protocol. So commands will come in from SCADA. The SCADA will send controls to this point where that control then will get replicated and sent to this device and this device and this device and this device, all, and typically they'll be equivalent points for a whole bunch of devices. So let's say, for sake of example, that we're going to send maybe some sort of a breaker control point from SCADA, and it's going to then trip out this device, this device, this device. It's going to do it to a whole bunch of devices. And that's the theory behind this control link function, is just to be able to send a command from SCADA that then gets assigned to multiple devices. So let's say SCADA, maybe a good example would be, I don't know, setting a bit for either non-reclosing or local remote or hotline tag or something, and then having those settings take effect on maybe all the relays in a sub. That's a reasonable example of what we might use that for. So that's a new feature that we have. Now, I mentioned that we had made a change, or really made kind of an addition to one of our existing functions, and that is KYZ relay. So let me go ahead and add here. Let me just pop points in for Y and Z. So as far as KYZ, as far as that idea goes in the power industry, we now, the theory into it is it's tends to imply an alternating or kind of a switching between Y and Z going high and kind of alternating back and forth. That now we've added the standard mode, and that's the way the standard mode works. The standard mode will measure a count based on, and with an emphasis on making sure that those pulses will alternate. And this, as I said, was kind of more in line with how the industry thinks of KYZ demand measurement. Now, averaging was what we had used previously in this KYZ relay function. Basically, it's a similar idea. It measures the count based on those Y and Z pulses. The difference is it did not include that requirement for those Y and Z points going high to alternate. So, and we have a few customers that had an application for Logic Pack functioning in that way. So we did keep it around. But for the traditional, the way the industry thinks about KYZ, people who are wanting that sort of functionality may be more satisfied with standard. So that is in here. And furthermore, we have set it as the default setting on this function now. So that's something to bear in mind for anyone who is using KYZ presently. Just a note for all of you. So that's the change we made to KYZ. That wraps up Logic Pack. There is one more thing that I wanted to show, and we're going to find that on the web interface because we added a feature, just a minor feature, but one you guys pretty much will know right away how it works because certainly you all have user accounts for a whole bunch of things. So if I go under authentication rules, and this pertains to the password, I'm going to go ahead and log in for that setting screen. And of course, I'm going to confirm it one more time. So the new thing we added to this screen under password rules, and I do not believe, this doesn't need to be checked for this to be in effect. This is a new field. Default days until expiration. That is the number of days until the password expires. And of course, it will prompt you to make a new password. By default, right, for people who don't need it, we wanted it to be as minimally intrusive as possible. So we set the default days to pretty much its maximum. This is probably about 30 years down the road. And by then, you probably, the Orion, they're great products, but you may not be, 30 years down the road, who knows? But, this expiration time is set pretty high. If you need it lower, if you need to change the password, say like every 3 months or so, you can set it to whatever you need. And with that said, that's the last thing that I wanted to show you. So with that completed, I will jump back to the webinar and I will bring us home. But Ryan, did we have any questions come in while I was demoing? Anything new come in?
Nothing about that, I don't think. No.
Okay. All right. Well, with that said, I'm going to go ahead and jump into our typical conclusion to the webinar, where I wanted to remind everyone about our customer community website. You can go to the customer community. Again, it is novatechautomation.com/community. You can also access it through the top bars in our main, from our main website. There's a link to the community. But on here, you can see a few things. You can see some documentation, some product drawings if you need them, training resources, a schedule of our upcoming training sessions, and of course our archive of these Power Hour webinars. This one and all the ones before it, you're going to find on the community. You'll be able to go watch them on your time. Also did want to point out our support resources that you can phone into our office in Lenexa, Kansas. It's 844-NovaTech. There are email addresses for support, both on the Orion and on our Bytronics meter products. And lastly, we do always draw special attention to this link here, book a call with an application engineer. And we'll get to that in a second. But the support site also, Ryan had talked about that previously, and this is where we go for product information, specifically firmware for these products. You can download NCD from there. You can go, My Files is kind of a special place that you can use in conjunction with our office support. But you can go here for all of those support needs. And lastly, the sales engineer booking page. This was the link I referred to on the customer community. This allows you to basically set a meeting time with someone at NovaTech, where the unique thing about this system, it plugs directly into all of our Outlook calendars. You can define a date and a time for a meeting that works for you. And you can select who you want. You can select someone specifically. You can select myself from the list. You can select anyone else on our team, and including 2 gentlemen on there who specialize in the Spanish language. If you guys, if you prefer to speak in Spanish, these gentlemen can help you out also. But you pick someone, or you can pick anyone, and we'll find the person who's best for you, and we'll meet at a time really of your choosing. With that said, guys, great resource. I recommend you guys look into that if you have a need, or certainly reach out to us directly. We have no problem with that also. With that said, that's the conclusion of the webinar. You'll see contact information for both Mr. Ryan McAuliffe and myself. And with that said, guys, I would like to thank all of you for attending the webinar. And this will be on the Power community again to watch again if you'd like to. Should be by the end of this week, maybe early next week. Yeah, and in closing, everyone, thank you for attending. Have a great rest of your day, and hope to hear from you soon.
Thank you all. Appreciate you.